everyone, I'm Alivio. We will report about magnetic fields and electromagnetic induction. You will know my classmates later, or my group mates, as you watch this video. Here's Darlyn and Casas for the report about magnetic field. Hope you like it.
Hi, I'm Darlyn Casas, here reporting you about electricity and magnetism. In a distant land in Asia Minor, 1,000 years ago, the Greeks discovered discovered a certain metallic rocks in the district of Magnesia could attract iron and attract or repel similar rocks. They referred to these rocks as magnets after the place where the rocks were discovered. Nobody thought that this discovery would become one of the most important components of science and technology. Electricity has two types of electrical charges, the positive and the negative. Analogous to this, a magnet has two poles, the north and the south. If you suspend the magnet in the air and allow it to rotate freely, its north pole will point to the geographic north of Earth.
Clauditte arcilla, here to report about the application of electromagnetic interaction. Electromagnetic interaction is responsible for the information of electric and magnetic fields around electric charges and currents. Electromagnetic interactions are used in communications and in medicine. It is used by the antennas like smart antenna system, helix antenna, and safe antenna. Smart antenna system is used as cellular base station antenna. It tracks vehicles as they move through a cell. Helix antenna for satellite communication for vehicles and other wireless applications. And safe antenna is used for handheld telephones.
Hi, let's go up to the problems involving magnetic field. Okay, the first problem. An alpha particle, which has 2 protons and 2 neutrons, traveling east at 2.0 10 raised to 5 meter per second, enters a magnetic field of 0.2 Tesla, pointing straight up. What is the force acting on the alpha particle? So, with a solution, let us first cite about the given. So, B equals 0.2 Tesla. V equals 2.0 times 10 raised to 5 meter per second. Q equals 2 times 1.6 times 10 raised to negative 19 coulomb. And the angle is equals to 90 degrees. And if our required is the force. For the solution, we have the formula F equals QVB sin angle. So you will just multiply all 2.2 times 1.6 times force equals QV B sin angle. Multiply 2 times 1.6 times 10 raised to negative 19 coulomb times 2.0 times 10 raised to 5 meter per second times 0.20 Tesla sin 90. So our force will be equals to 1.28 times 10 raised to negative 14 Newton. And let's go to our second problem. A particle with a positive charge of a 3 coulomb moves upward at a speed of 10 meter per second. It passes simultaneously through a magnetic field of 0.2 Tesla, directed into the page and electric field of 0 Newton over coulomb, directed to the right. How is the motion of the particle affected? In answering this question, it's a matter of calculating the force exerted by the magnetic field and the force exerted by the electric field. Then adding them together, induction. The generation of the electromotive force and current by a changing magnetic field is called electromagnetic induction. So, the electromagnetic induction is the idea of Faraday and Henry was based on their observation that the electric current could be produced in a wire by simply moving a magnet in and out of the coil. So, they discovered that the voltage needed to set current was caused or induced by the relative motion of the wire in the magnetic field. And so, magnetic flux measures the quantity or the strength of magnetism, which considers the magnitude of the extent of its field. So, the magnetic induction states the following. The induced EMF in a coil is proportional to the product of the number of loops and the rate at which the magnetic flux changes within the loops. And now let's have the experiment.
Go to the scientists who contributed a lot in electromagnetic induction. Joseph Henry, born on December 17, 1797. Henry was work on the electromagnetic relay was the basis of the electrical telegraph, and invented by Samuel Morse and Charles Wheatstone separately. Henry was a member of the Lighthouse Board from 1850 until his death. He was appointed chairman in 1871 and served in that position the remainder of his life. He was the only civilian to serve as chairman. Michael Faraday, born on September 22, 1791. Faraday discovered that many materials exhibit a weak repulsion from magnetic fields. Faraday also discovered that the plane of polarization or of linearly polarized light can be rotated by the application of an external magnetic field.
The electromagnetic induction. The generation of the electromotive force and current by a changing magnetic field is called electromagnetic induction. So, the electromagnetic induction is the idea of Faraday and Henry was based on their observation that the electric current could be produced in a wire by simply moving a magnet in and out of the coil. So, they discovered that the voltage needed to set current was caused or induced by the relative motion of the wire in the magnetic field. And so, magnetic flux measures the quantity or the strength of magnetism, which considers the magnitude of the extent of its field. So, the magnetic induction states the following. The induced EMF in a coil is proportional to the product of the number of loops and the rate at which the magnetic flux changes within the loops. And now let's have the experiment.
Hi, now it's the point that we will interview some of the people who are already known
My
on
name is
this.
Darlyn. I am from Achievers Airline College. As what my teacher told you when I was in my high school years, Electromagnetism is a study of interaction between electrically charged particles and magnetic fields. We can use electromagnetism in different ways, like in communication purposes and in
We hope you like our videos.